Hello everyone, well here we go, we're doing the North Atlantic Oscillation forecast for the winter of 2015-2016 in today's video. This is the fourth NAO forecast that we've done at gasweathers.com. The first one was in 2012 for the winter of 12-13, and then we did a couple more in 2013-2014. So this is the fourth North Atlantic Oscillation forecast, and it's for the winter of 2015-2016. This is sort of the starting point of the winter updates. After this, everything will go very, very quiet in terms of the winter forecast at gasweathers.com until September, when we will start doing all of the updates on a weekly basis, and we'll be starting in September. But this sort of will make up the first starting point of all of those updates in September, if you like. So, pretty exciting day at gasweathers.com. It's going to be quite a long video. I hope you enjoy it. But before I get on with that, just say about the ads. There's links to articles on all the pages at gasweathers.com. You could have a browse through widgets and click through any of the articles that you're interested in. You'll be helping to pay for the website. Thanks so much for getting involved. And thanks for doing that. Just to say about the North Atlantic Oscillation, first of all, what North Atlantic Oscillation is, and how it sort of impacts our winter weather. If you know about the North Atlantic Oscillation, and you know about the connection between May sea surface temperature anomalies and the coming winter, then I would suggest that you skip on about 10 minutes or so until we get to the actual forecasting part of the video. I have to assume, and I'm sure a lot of people will be watching this for the very first time, I have to assume that everybody's watching for the very first time doesn't know what North Atlantic Oscillation is, and what the connection is between May sea surface temperature anomalies in the Atlantic Ocean and what happens, or what can happen, in the subsequent winter. So I'll talk about that first of all, and then we'll go on and do the actual forecast for the winter of 2015-2016. So let's just start off talking about the North Atlantic Oscillation first of all. The North Atlantic Oscillation is an index that reflects the state of the atmosphere in the North Atlantic Ocean. So when the index is positive, it's telling us that we've got strong westerlies really coming across the Atlantic Ocean. So this chart from the 29th of December 1974 is a fantastic sort of representation of a positive North Atlantic Oscillation. We've got low pressure up around Iceland and Greenland, a very intense polar vortex, got high pressure reaching from the Azores into Spain and Portugal and going on into France, and we're bringing these strong westerlies across the Atlantic Ocean, a pretty strong jet stream moving through. So that's what a positive North Atlantic Oscillation looks like. And we can see another example of it from 2011. This is from Boxing Day, 20th of December 2011. And again, the same idea. We've got the strong polar vortex here around Greenland and Iceland, indicated by these purple colours. And then we've got the ridge of high pressure coming off the Atlantic into Spain, Portugal and France, extends back to the Azores essentially, and you notice tightly packed ice bar, so it's windy, winds are mild from a west or southwesterly type direction. And again, that's a very, very good representation of a positive North Atlantic Oscillation. You have to remember with this that the index is just reflecting the state of the atmosphere. It's just reflecting this setup. The index is not driving. It's not driving the weather at all. It's just reflecting what the weather, what the atmosphere is doing. So that's how a positive North Atlantic Oscillation looks. The opposite of that is a negative North Atlantic Oscillation. And this chart from the 30th of December 1962, from that incredibly cold winter of 62-63, again is a good representation of a negative North Atlantic Oscillation. Look, but it's totally flipped around. So instead of the low pressure and the polar vortex up around Greenland and Iceland, we've actually got high pressure, and the low pressures are to the south of that high pressure, going through the Azores, through Portugal, Spain, into France. So where we've got the high pressure to the south and the low pressure to the north, with a positive North Atlantic Oscillation, with a negative North Atlantic Oscillation, it's totally reversed, and that's called northern blocking. When you get that pattern, you turn it cold across Europe and across the United Kingdom as well. It turns bitterly cold. It can turn very cold in North America also. So that's how negative North Atlantic Oscillation looks. We can see another example from 2010, a very, very extreme example of a negative North Atlantic Oscillation. This is about as extreme as it can get, really, in terms of the blocking pattern. Look at all of this blocking up here across the Arctic and extending down into Greenland, going down into the Atlantic. Very, very extreme blocking pattern. This was, as I say, it's about as extreme negative NAO as it can get. And obviously you push all of that cold air out of the North Pole and into the mid-latitudes, and that was a very, very extremely cold month in December 2010. So that's the difference between a positive North Atlantic Oscillation and a negative. The key thing to remember is that neither index is driving anything. The negativity or positivity is not driving the pattern, it's just reflecting what the atmosphere is doing. So there's a connection between the sea surface temperature anomalies that we get in May in the North Atlantic Oscillation and whether we can get these blocking patterns in the winter that produce the negative North Atlantic Oscillation, or whether we sort of enhance the westerliness through the winter and we get that positive North Atlantic Oscillation. What we look for in May to precede the chance of a negative North Atlantic Oscillation is a tripole. And what a tripole is, it's this, what you're looking at here from May 2010. It's three distinct bands of temperature anomalies. So we have a warm band around the south of Greenland and going down to Newfoundland. Then we have a cold band through the central part of the Atlantic, and that usually extends back to the eastern seaboard of the United States. And then we have a third warm band, a trilogy of warm, cold, warm through the tropics. Looking for a band of warmer water going through there. When you get that signature in May, it can often precede a recurrence of that to occur in the winter. And when you get this sort of warm, cold, warm band, a tripole in the winter, when you get that, very often it coincides with blocking in the northern latitudes, and that coincides with a colder than average winter. Why this happens is not reasonably well understood. Why May is important for what may happen as you go through into winter, it's not all that well understood. I think it's probably because May tends to be one of the less vibrant times in the North Atlantic, if you like. It tends to be one of the quieter periods where the natural state of the Atlantic Ocean itself can sort of come to the fore. And of course that natural state varies year on year. It's not a continuous state. You get variability within the Atlantic sea surface temperature anomalies year on year. And in May, it tends to be the case that it sort of goes to its natural sort of position through that year, and then that can reoccur as you get through into winter. This is a UK Met Office methodology originally, I believe. They used to use this very regularly. I think they still perhaps do use it for some of their sort of private forecasts. They don't really issue long-range forecasts to the public now, except for the contingency planners guidance that they do, which is excellent, by the way, and do check that out if you can. But in terms of a long-range seasonal forecast, they don't do that quite so much, but I think they still do look at the sea surface temperature anomalies in May with a view to what could happen as you go through to winter. So that's how a tripole looks anyways. We can go through now and have a look at this chart from last year. This made up part of last year's North Atlantic Oscillation forecast. And you see, but we quite clearly do not have a tripole through this month, through May 2014. What we have is an area of cold here in the central part of the Atlantic. It's a bit warmer down here, perhaps, but not really desperately warm anywhere through the tropics. Actually, it's about normal sort of temperatures there, and it's cooler up here. So this definitely is not a tripole. And of course, the last North Atlantic Oscillation forecast that we issued at the end of May 2014 was for a positive North Atlantic Oscillation. We predicted that there would be a positive North Atlantic Oscillation based on how the May sea surface temperature anomalies were stacking up through the month of May 2014. We did in fact get a positive North Atlantic Oscillation through the winter of 2014-2015, so I was quite pleased with how that element of the 2014-2015 forecast panned out. Remember, this is only making up around 5%, perhaps maybe 10% of the final Gauss-Ovitz forecast, which won't be issued until the start of December. So this is just one part of a much bigger puzzle, one part of a one ingredient perhaps of a much bigger cake. It certainly isn't the final say on the matter. We have a look at another year that didn't produce a negative North Atlantic Oscillation. So this is from May 1999, and again you see that we don't really have a tripole. We have quite a warm Atlantic. It's a bit cooler around Newfoundland, but other than that, generally the Atlantic through May 1999 is in quite a warm state, and there's certainly no sort of tripole of warm, cold, warm over the top of one another. It's just the fact that the Atlantic is in generally quite a warm state through May 1999. So you again look at that and you say that progressing forward into the winter, you are very unlikely to get a tripole, which means you're very unlikely to get a negative North Atlantic Oscillation. You're very unlikely to get that blocking setting up. This has about a 1 in 3 success rate, though, so there are years that do deviate, and the pattern that you're getting made does not reoccur in the winter. You get something different. So it's, again, by no means a done deal. What we're predicting here, about a 1 in 3 success rate. So fairly reasonable success rate, but sometimes you get years that do deviate. But this one actually preceded a mild winter 99-2000, saw strong westerlies across the Atlantic, a positive North Atlantic Oscillation. So the theory did work out quite well during that year as well. And then finally, a year that had a negative North Atlantic Oscillation is 1995-96. So this is the sea surface temperature anomaly from May 1995. This looks a little bit different because it's a long time ago, or a fairly long time ago. So the projection and everything else looks a little bit different, looks a little bit basic. But the overall idea, and you have to ignore this blue area that we've got up here to the south of Greenland, that shouldn't be there. Actually, all this area should be warm. So the idea is that you've got this warm area to the south of Greenland. Then it goes cold off the coast of Newfoundland, off the coast of North America, really quite cold there. And then you've got it warmer down there through the Azores and going down into the tropical Atlantic. It's a little bit different, that, but basically it's still the idea that you've got the warm band, the cold band, and then the warmer band underneath it. So you've still got that idea of the tripole going on, and of course we will predict a negative North Atlantic Oscillation from that. The winter of 95-96 had a negative North Atlantic Oscillation. It was a cold winter, one of the few cold winters actually through the 1990s in the United Kingdom and Europe. So that's what we're looking for. We're looking for a tripole. So let's have a look now at how the May sea surface temperature anomalies from 2015 have been developing. So now we're progressing on into the actual forecast part of the video. So we start off on the 4th of May 2015. And what's evident here is that we've got a fairly chilly North Atlantic, actually. We've got quite a lot of cold water around here, cold sea surface temperature anomalies. And then it turns a little bit nearer normal through the central part of the Atlantic. And then it's cold again off the coast of North Africa. No great body of warmth, except perhaps around the Caribbean, It could be a bit warmer there, but overall quite a chilly North Atlantic as we started May 2015. And certainly no sign of a tripole, no sign of that warmth underneath Greenland, south of Greenland. Actually, quite cool. Now, as we progress on through the month, we see that actually the North Atlantic turns colder. So here we are on the 11th of May, and definitely an expansion of those blue colours, an expansion of the cold sea surface temperature anomalies there across the northern part of the Atlantic. If we progress on further, we can see that those cold anomalies get colder as we go through into the 21st of May. So we have seen a very cold North Atlantic actually through the course of this month. It's been the coldest that I can find, probably going back to the 1980s, can you believe, at this time of year anyway. I've not looked at every month and compared back in time, but certainly for May, I can't find a year that's as cold as this May in terms of those sea surface temperature anomalies in the North Atlantic Ocean, going right the way back into the 1980s. And that was, of course, the time of the cold Atlantic multi-decadal oscillation. So we can see that the AMO, the Atlantic multi-decadal oscillation, has definitely gone cold, or it is cold at the moment, and that deviates from where we should be, really. We should actually be having a warm Atlantic at the moment, although probably as we get toward mid-2020s, you would tend to think that the AMO will start to cool down. So this could be sort of the first hint to it. I would expect the Atlantic to start to warm up again over the next few years. I don't think we're definitively in the cold AMO yet. It's too soon for that because we only went warm in 1995, 20 years ago. So you will think that probably got another 10 years of the warm AMO to continue. But I think this is probably the first hints of what lies in store, if you like, as we get through into the 2020s. Anyway, I'm digressing with that. I'm off on a tangent. And let's get back to the NAO for winter of 2015-2016. So on the 21st of May, cold Atlantic there, across much of the North Atlantic, certainly no tripole. If anything, it's the reverse of a tripole. And that's how we go through to the end of May 2015 as well. It just gets colder through the course of the month in terms of those Atlantic sea surface temperature anomalies. So what we've got as we end May 2015 is the reverse of a tripole. If anything, we've got a cold area to the north. We're warm through the central part of the Atlantic. We probably go cold, or do go cold again through much of the tropics. It's only around the Caribbean, in that sort of zone that we've got warmer waters. Otherwise, through the tropics, it's generally quite cool. This will probably have an impact on the hurricane season, by the way. It probably limit hurricanes that develop in the central part of the tropical Atlantic, but we may get more developing around the coast of America, so that could be something to watch out for. But anyway, in terms of the Atlantic, the broader picture of the Atlantic Ocean, we don't have a tripole, we don't have warm, cold, warm. What we actually have is cold, warm, cold. And the forecast for that is for a positive North Atlantic Oscillation for the winter of 2015-2016. You can't really look at that and predict anything other than a positive North Atlantic Oscillation coming out of the winter of 2015-2016. But there are caveats to this, and the first one, of course, is that it's a 1 in 3 success rate. So just because this is what it's showing now, we've got this positive North Atlantic signature, North Atlantic Oscillation signature now, doesn't necessarily mean that it will go through to winter. Something else could emerge. And the other caveat, of course, is that this is only one part of a much bigger picture, and we've got to look at all the other things that we do look at through the autumn, and I won't be starting the updates until September, so everything goes very quiet now at GeoService around the winter until we get to September. But the other point is that once we get through to the autumn, once we get through to September, we'll be looking at all those other things that are very important, such as what's going on with ENSO and more broadly in the Pacific Ocean, what's happening with solar activity, how quickly the snow cover advances across Siberia. All the things that you know are very important for GeoService.com, what we look at GeoService through the autumn before we make our final forecast at the start of December. Just want to show you this. The charts, the sea surface temperature anomaly charts, for the 1980s look like this. So this is May 1985. Now this is right in the middle of the cold Atlantic multi-decadal oscillation era, which runs from around the mid-1960s to the mid-1990s. These cycles usually run around 30 years. So the cold AMO starts sometime around the middle 1960s, probably just after winter 62-63 actually, and then it runs through to 1995. So this is right in the middle of the cold AMO, and look how cold the Atlantic is through this month. Very, very, very cold Atlantic. Bear in mind this is a different projection because it's a long time ago, so it looks more basic, but you get the idea that the Atlantic, more or less universally, from the equator to Greenland, is in a very cold state. And May 1986 also shows a very cold state with the North Atlantic North Atlantic sea surface temperature anomalies. Now, both of these winters were cold winters, 84-85, 85-86. So even though the Atlantic through May of both 85 and 86, you would look at it and assume that that is a signature for a positive North Atlantic oscillation. That would have to be the forecast. But just because you've got that sort of state does not mean that you can't get a cold winter, because both of those winters, 84-85, 85-86, were very cold winters in the middle part of the 1980s. There's a lot of other things going on, and the main thing about those winters in the middle of the 80s was probably that was around solar minimum, was in the depths of solar minimum around 1985 and 1986. So that just backs up the point that I was making, really, that the North Atlantic Oscillation forecast only makes up around 10%, 5-10% of the broader AbsoluteVids.com winter 2015-2016 forecast. We will look at solar activity and all of the other things once we get to September. That's when we'll start doing the regular updates. So it's a mixed bag, but the actual forecast for the winter of 2015-2016 in terms of North Atlantic Oscillation is for a positive NAO, because we've had cold sea surface temperature anomalies in the Atlantic Ocean through May 2015. But it's by no means the end of the story. So it'll go quiet now on the website and with the updates until September, and then in September is when things will really start ramping up. Okay, that's it for now. I hope you found the video interesting and informative. Hope I haven't rambled on too long. That's all for now. Thanks for watching.